If you have an off-grid or hybrid solar PV system and you're wondering what the earth neutral bridge is and what it's for, this video is for you. My name is Karel Ballack. I've been presenting solar PV and electrical engineering training for more than 15 years. In today's video we're going to be looking at the earth neutral bridge, and the right place to start would be at the transformer. So when we look at a normal transformer in any AC environment, we have a transformer. The transformer consists of three coils. Let's just simplify it slightly. So we've got three coils. And the easiest way to draw these coils is to draw them where the three coils are joined at the center. This is called a start point. At that point in the middle, where all three of the coils get together, they normally take that point, bring it down, and that becomes the neutral. What they also do is they take that point and that becomes the earth. So in a normal electrical installation, your neutral and your earth is common. Now, when we have this line running through to our house, so we've got our DB board sitting over there, we've got the DB board sitting over there, and we've got this going through to all our loads. Our neutral and our earth point is common. Now, when we install a hybrid inverter, or we are planning on taking this part of the installation off grid, we've got to try and mimic this environment, because this point over here is the point that makes the earth leakage function in the way that it's supposed to function, where it trips when there's accidental contact. If someone gets shocked, your earth leakage trips because of that point over there. Now, if we were to install an inverter over here, so we install a hybrid inverter, if we let's just do that, where we've got that's our hybrid inverter. Got the solar at the top, we've got the battery at the bottom. In the event where the utility supply falls away, what we are also losing is we are losing the reference to earth. We have to recreate this reference to earth in order to get the earth leakage equipment in the DB board to function. Now, the way that I've drawn this is probably not entirely correct. We would end up having another DB board over there to be able to isolate, or whatever the case may be. The arrangement over here could be fairly complex. You could have some of your loads sitting on a dedicated DB. So you could have split loads where one half of your house is powered by your inverter and the other half powered by the grid or the utility. So the way that I've drawn it over here is extremely simplified. So we've got a DB, we've got an inverter, and we've got another sub DB downstream. The only way that the earth leakages is going to be doing anything on this installation is if we bond the neutral and the earth point on this inverter over here. Because in a load shedding environment, that point is going to fall away, and we need to create or recreate a new earth point or new reference to earth. So we have to recreate the start point that we have in the transformer, has to be recreated over here. Now, there are lots of arguments around this. The one is to say, well, let's fit a relay. The other way is to fit a hardwired earth neutral bridge. So when we fit a hardwired earth neutral bridge, this could potentially be fairly dangerous, because what happens in the event where this line or that connection gets stolen or damaged, which in certain countries is more common than not. If that cable gets stolen and the earth reference is lost, you would find that the entire electrical network in the vicinity of this installation is going to rely on the earth neutral bridge of this inverter. So this point then becomes the point that the utility relies on, and that could be very bad for your equipment. So the hardwired way of providing an earth neutral bridge is a solution, but it's not ideal. Providing a relay is a solution, but relays or contactors fail. So when you use a relay, you have to make sure that you test the relay regularly to ensure that if there is something that goes wrong on your installation, the users or the people, the consumer or the user using the downstream side of your energy supply is protected by the earth leakage. So this is not ideal, because it could become the main earth reference for the utility. That is not ideal because it has it's another point of failure. The relay is the preferred method of providing an earth neutral bridge. Some inverters have the earth neutral bridge built into the unit, and some of the inverters you have to supply a contactor or a relay next to the inverter in order to activate the earth neutral bridge in periods or during periods where the grid falls away. Let's quickly have a look at what happens when we don't have an earth neutral bridge. So the catch to this test is that we've got to simulate a load shedding. At the moment we can see we've got our AC supply over here, so the municipality is busy supplying us power. If we want to understand the neutral earth bond, that's the place where we start, because at the moment we're getting our neutral earth bond from the municipality or from the municipal supply, and that neutral earth bond at the moment sits in the transformer. AC has just been switched off, so at the moment it's operating in island mode. If we do the same test now, we'll find that between neutral and earth we are sitting with 90 volts. And the only difference at the moment is that we've simulated load shedding conditions. So that voltage shouldn't be there. Now, the Daya 3-phase inverters have the neutral earth bond built in. So if we go back and we activate the neutral earth bond, now settings, advanced function, signal island mode, yes, I've now changed the settings for it to signal island mode. So theoretically, if we redo this test again, we're going to switch off the power and redo the test. Switched off the power, and now if we measure between neutral and earth, there's 0 volts. So this is with the earth neutral bond being activated or selected in the Daya settings. Okay, now with the neutral earth bond we can do the loop impedance test. We'll move this to the no trip function. Connect our earth. It's given us the all clear because those lines over there are solid. Line and neutral is solid, so I can run my test. Excellent. Gives us respective short circuit current 1.3 and 176 amps. So if you don't have the neutral earth bond connected, you won't be able to conduct this test depending on what your installation configuration is like.